Start off talking about the exam review here. It probably should answer some of your questions about the active engagement assignment as well. So let's just go ahead and get started on that. And I'm going to be using the computer to do it today because I have nice pictures, so I might as well use my nice pictures, right? And so I figured since I'm going to be doing that, I'll go ahead and record it as well. So it probably won't be up online until like Wednesday, though, something like that. Yeah, yeah, probably Wednesday morning. So definitely, it's a good idea you're here in person. All right, so let's see. On problem one over here, we're told that this is a sine wave, basically, right? And remember, there's no distinction between a sine wave and a cosine wave. They're the same thing, just shifted, right? So the fact that I had to actually tell you this, right? That I want an equation of the form y equals a times sine of bx minus c. Oh, thank you. So a times sine of bx minus c plus d. I had to tell you that, right? Okay. So now that I have told you that, though, all right, now that we have this is the type of equation that we're looking for, now we can go about trying to find a and the b and the c and the d that work. Okay. And our very first step here should be to just draw a sine wave, basically. Yeah, like look at the graph and what does a sine wave look like? Right. Well, ideally, a sine wave would look like this. It starts on its axis of symmetry, goes up and then down to its minimum and then back up. And so ideally, that's the kind of shape that you want to see. And unfortunately, this graph is not quite big enough to accommodate that, right? Like you can see that like somewhere back here where the graph cuts off is where it starts and it goes up and then down and finishes over here. Okay. But that's okay. We still have enough information to do this. So if I started from here, for example, right, where it touches the axis of symmetry, and start tracing downwards and then back up and then back down again like that, right? Well, that's just an upside down sine wave, right? So we can use that and have our a just be negative, right? So we're going to have an upside down one, right? Which means that our a is negative. Yeah. So yeah, once you realize that that it will touch at -2, yeah, that's perfectly fine. Yeah, okay, yeah. So basically, because of the periodic nature of this, you do know that like if we go back 4 steps from here, right, we should be at a place where it touches the axis of symmetry right here at x equals -2. So yeah, you could do it that way as well. Yeah. Okay, but I'm going to do it this way with the upside down one. Okay. So now that I have that, right? Now let's start like just drawing some features on this graph, right? So first of all, the amplitude, right? So the amplitude is the distance between, and you can use a maximum or you can use a minimum, it doesn't matter, right? I guess I'll use the maximum over here. Okay. So the amplitude is the distance between the axis of symmetry and your maximum y value of your function, right? So that's your amplitude, which in this case is just going to be 2, right? Okay. Any questions on that? Can you guys read that in green, by the way? Yeah. Uh-huh. Right. Oh, okay. So when I get to actually computing what A is, that's going to matter. Yeah, yeah. So yeah, like yeah, but for right now, like yeah, you can clearly see on the graph itself that the amplitude is 2. Right. So how do you show your work on the exam? Right. Off to the side over here, you just say that the amplitude is 2. Right. That's it. Yeah. I looked at the graph and I found out that the amplitude was 2. Yeah. Okay. Fair enough. So not a whole lot of work to show there for that. Right. Same thing with the vertical shift. The vertical shift is just wherever your axis of symmetry is, right? So here's your axis of symmetry, right? That dashed line right there, right? Which happens to be at y equals 1. So that's your vertical shift as well, right? Vertical shift is 1. Okay, so those are easy. Yeah, those ones are not too bad at all. Okay, let's do the horizontal shift, right? So remember that if you're starting your sine wave, that first key point is supposed to be on the y-axis. So if it's not, then that means that you have some kind of horizontal shift. So from here to here, that distance, that's your horizontal shift. Horizontal shift would be 2 in this case. Yeah. Any questions on that? Right, that's probably the hardest one, right? So this is why I think it's important to like go ahead and draw on your graph where you're starting your sine wave, right? Yeah, so that way you know what your horizontal shift is just by looking at that. Okay. Okay. And so if you had realized that you could start your sine wave over here at x equals -2, right? Then yeah, you could do that and you could say your horizontal shift is -2 instead, right? Yeah. All right, and then now we're going to do the period, right? And the easiest way for me to measure the period in this case is just go from peak to peak, right? From maximum Y value to maximum Y value, right? That's clearly 8 units across, right? So this is one full period, right? You can go from minimum to minimum, or you can go from maximum to maximum. It doesn't really matter, right? So the period, which I'm going to use T for that symbol, is 8 in this case. Yeah, so T equals 8. Okay. So now I've done everything that I needed to do by looking at the graph. Okay. Yeah. So now I have those features. Okay. Yeah. Now I still have to calculate what A, B, C, and D are. Okay. But any questions on that? 'Cause I think that's probably the hardest part of this. So any questions on that at all? All right. Well, now that we have that, okay, now we can go to our formulas. So the amplitude is always the absolute value of A, right? But because I have an upside down sine wave, because I chose to start it over here, it's upside down, that means that my A is going to be a negative number. So I really have negative A. Yeah, fair enough. And so negative A is my amplitude, but my amplitude is also 2. So then negative A must be equal to 2, right? And so that means that A is equal to negative 2. Right? Any questions on that? Any questions at all? Yeah. So the amplitude is 2, right? But the amplitude is also negative A in this case. Oh, why is it negative A? Right, right. Okay, let me explain that. Okay. So the absolute value of A is what the amplitude is, right? Yeah, but what is the absolute value of X, right? It's a piecewise function. Yeah. It's equal to X if X is positive, right? Or greater than or equal to 0, I'll say, right? And it's equal to negative X if X is negative. So if you have a negative number, multiplying it by -1 makes it positive. Yeah. So then the absolute value of A will be equal to negative A because A is a negative number. Let me explain that one more time. I have negative right here times another negative right here. So this quantity is positive, right? A negative number times a negative number is a positive number. So this is positive. And that's what the absolute value is. It's the positive version of A. Yeah. So this is a college algebra thing, right? Where we talk about piecewise functions, right? Yeah. Okay. So you can remember that fact, right? You can remember that the absolute value of X is always equal to X if X is non-negative, and it's equal to negative X if X is negative, right? Yeah. Oh, so in that case, you would have a right side up sine wave, right? Yeah, if you were to start at X equals -2 over there. Right. And so because it's right side up, you just have the absolute value of A is just A. Right. Yeah. Okay, but it's because I started as an upside down sine wave that I have a negative A value. Okay. Yeah. Yeah. Okay. Yeah. Yeah. Okay. Yeah. It's because I have the upside down sine wave that you know your A is going to be a negative number. Okay. Yeah. Okay. So then now vertical shift, right? Vertical shift is always equal to D, right? And so we found out that our vertical shift was 1, right? So then D is equal to 1, right? So that's pretty easy. Okay. Now we're going to do our period. The period's the next one. You want to do your period before the horizontal shift because the horizontal shift relies on your period, right? So you got to know your period first. Okay. So the period formula is for sine and cosine, it's 2 pi divided by b, right? Fair enough. That's your period, right? 2 pi divided by b. Okay. But we also just looked at the graph and saw that the period was equal to 8, right? So I have that 2 pi divided by b is equal to 8. So we got to solve for b, right? So this requires a little bit of algebra here, right? We could multiply by b on both sides. We get 2 pi is equal to 8b, right? And then we could divide by 8 on both sides. And we get that b is equal to 2 pi over 8, which is just pi over 4, right? After simplifying. 2 pi over 8, pi over 4. Okay. Yeah, so that one is probably the one that requires the most work. Yeah, that and the horizontal shift, which comes next. Okay. Yeah. Okay, questions on that? All right, well, let's do the horizontal shift then. And the horizontal shift is always C divided by B, right? Okay. And remember, we're assuming that our B is positive for all of these formulas, which we can always find a positive B value that works. So don't worry about it. Okay. Now, horizontal shift is always C divided by B, but we already looked at the graph and saw that the horizontal shift should be 2, right? So then C divided by B is equal to 2. I could multiply by B on both sides, and I get that C is equal to 2 times B. But I already know that B is pi over 4. So C is equal to 2 times pi over 4, which is pi over 2. Okay. Any questions on that? See, that's a pi right there. Okay. Yeah, you could. Yeah, you could do C divided by pi over 4 is equal to 2, right? But then you'd multiply by pi over 4 on both sides to get it out of the denominator anyway. So you'd still wind up with C equals pi over 2. Okay. All right. Any questions on that? All right. So then now I have my A, B, C, and D. I'm not done yet. Okay. I actually have to write out the formula, and if you don't write it out, then I'll take off a point out of 10, basically. Right. So y is going to be equal to, well, my A is -2, right? Sine of my B is pi over 4, right? Times x. My C is positive pi over 2, right? And my D is 1. Okay. So that's my final answer there. It's worth 1 out of 10 points, right? Yeah. To plug in what your A, B, C, and D are in that formula. Okay. Yeah. It could be, depending on where you started. So if you started, yeah. Yeah, exactly. If you started at x equals -2 over here, right? Then you would know you have a right side up sine wave, right? And so your A would be +2. Your horizontal shift would be a -2 instead, though, right? So you would have basically a plus of pi over 2 over here. Okay, fair enough. All right, any other questions on that? Oh, so the original equation, which is why I made sure to write it up here, just so you would have it for reference. It has a minus sign. Yeah, fair enough. Yeah. So if your C is positive, then you should have a minus sign on the inside. Exactly. Exactly. Okay. All right. Now we're going to do the same problem, right? So problem 2 is the exact same problem, exact same graph, but now we're treating it as a cosine graph instead. Okay. Instead of sine, we're treating it as a cosine graph. But remember, sine waves and cosine waves are the exact same thing, right? Yeah. They're just shifted. Yeah. Now, I'm going to go ahead and start off the same way. I'm going to draw my cosine graph, which remember that starts at its maximum y value and it ends at the next maximum y value. So we're going to trace it all the way down over here. Okay. All the way up to its maximum y value. Oh, nope, not like that. Not like that. All the way up like this. All right, there we go. Okay, so that's one full cosine wave, and it's right side up, right? Okay, so any questions on that, first of all? And the difference between drawing the sine wave and the cosine wave? Yeah, so the sine wave looks like this. I'll draw 2 pictures up here. Sine wave starts on the axis of symmetry, goes up and then down and back to the axis of symmetry. So this is sine, right? But cosine starts at its maximum, goes, what the hell is that? I don't know. Goes down and then back up to its maximum. That's cosine right there. Okay. So because we're doing a cosine equation over here, that's what we want to look for. Okay. Yeah. Okay. So now that we have that, right, now we can start doing the same thing as before, drawing our key features, right? We still have the vertical shift is right here at the axis of symmetry. So the vertical shift is 1, right? We still have the amplitude is just the distance between the maximum y value and the axis of symmetry. So our amplitude in this case is 2 still, right? Our period, right, goes from maximum y value to maximum y value, right? So that distance right over there is your period. We got t is equal to 8, right? Okay, so the only thing that's going to be different about this, because we're talking about cosine instead of sine, the only thing that's going to be different is our horizontal shift, okay? For the regular old cosine graph, we're supposed to have that our first key point lies on the y-axis, okay? And it does, right? Our first key point right over here does lie on the y-axis. So then my horizontal shift is just 0 in this case, because it's exactly where it's supposed to be, okay? Yeah. Any questions on that at all? Any questions on that? Okay. So because it's where it's supposed to be, the horizontal shift is 0. We haven't shifted it at all. Okay. All right. So when you show your work on the test, you could write it on the graph like I did, or you could just write it off to the side over here, right? Amplitude equals 2, right? Vertical shift equals 1, period equals 8, and horizontal shift equals 0, right? You can write it on either place, basically. Okay. But now that I have that, now I can do our formulas, right? Which are the exact same formulas as they were for sine. Exactly the same formulas. So the amplitude is still the absolute value of A. Okay. Now, when we did this problem in problem 1, it was an upside down sine wave. So we had our absolute value of A was negative A, right? Okay. But now our cosine wave is right side up, right? This is the way that a cosine wave is supposed to look, starting from its maximum and ending at its maximum. Okay. So then our absolute value of A is just going to be A in this case. Yeah, because it's not upside down. Okay. And so that's just going to be equal to 2. Okay. Any questions on that? Okay. All right, now we'll do our vertical shift. And the vertical shift is always D, but our vertical shift is equal to 1. So then D equals 1. Okay. That's going to happen occasionally. Sorry about that, everybody. Yeah. So vertical shift equals D, which is equal to 1. And then now we go to the period, right? Which is still 2 pi divided by B, right? And so we said the period was 8. Okay, so we got B is equal to pi over 4 again. I showed my algebra for that in problem 1, so I really don't need to show that again, right? Fair enough. Yeah, B is just equal to pi over 4. Yeah. And then now we go to the horizontal shift. And the horizontal shift is C divided by B, right? But we said the horizontal shift for this cosine wave was 0. So we have that C must be equal to 0, right? Okay. So any questions on that? On computing either of those 4 parameters there? Well, I mean, you got to say that C is equal to 0, right? Yeah. Fair enough. Yeah. But like actually showing your work for how you know the horizontal shift is 0. I mean, it's fine if you just look at the graph over here, right? Yeah. Once you just draw your cosine wave, it's pretty clear to see that the horizontal shift is 0. Yeah. Okay. Yeah. Now, right, we just plug everything in. So we have y equals positive 2 times cosine of pi over 4x. You don't have to put minus 0 or plus 0 on the inside, right? You just leave it off if it's 0, right? And then plus 1. Okay. And that's your equation. Okay. Any questions on that? Any questions on that at all? Okay. Well, then let's go on to the tangent wave, right? It's not really a wave, right? Because it's discontinuous, right? But the tangent function here, right? So we're looking for something of this form, y equals a tangent of bx minus c plus d. We're going to start off the exact same way we did for some. We're going to draw like one full period of tangent on there. Okay. And you can start with any of these that you want. I'm just going to start with the one that's closest to 0, basically, right? So remember that your tangent function starts at a vertical asymptote, right? So here you can see there's a vertical asymptote right over here on the y-axis, right? And then your tangent function ends at the next vertical asymptote, okay? So here's the next vertical asymptote right there, okay? So that's one full period right there. So let me just go ahead and do the period while I'm over here, okay? All right, that's one full period. So the period is 2, okay? Any questions? Any questions on that? Okay. All right. All right. So then the tangent wave is right between these two vertical asymptotes. So I'll go ahead and draw that in here. Okay. Here we go. So that's the one we're looking at there. Okay. Let's do my vertical shift, right? Just wherever the axis of symmetry is. So the vertical shift is 1, right? Okay. Let's do my horizontal shift, right? And so I'm just going to draw the general shape of tangent up here, right? So here's my x and y axis, right? It's supposed to look like this. supposed to be symmetric about the origin and go right through the origin right there. That's what it's supposed to look like, right? Your middle key point, right, is supposed to be on the origin, right? So your horizontal shift, right, will be wherever this middle key point is. Yeah, that'll be your horizontal shift. Okay. So I'm going to label that, right, from here to here, that distance from there to there, that's your horizontal shift. Yeah. So it's fine if you don't draw all that out. That's fine. Yeah, if you just like say your horizontal shift is equal to 1, your T is equal to 2, your vertical shift is equal to 1, right? And if you get it wrong, I'll mark it off, so basically. And then when you go on to calculate your A, B, C, and D, I'll carry forward whatever error you might have made. Okay. Yeah. So using what you found in that first part, here's what you should have gotten for A, B, C, and D, right? Yeah. Okay. Yeah. Okay. So the very last thing is amplitude, which is never fun on a tangent graph, right? So here's how it works, right? So we have to find out where your y2 or your y4 is, right? So that's the goal here. So I'm going to use between here and here. Okay. So this is my x1, this is my x5. That's one full period, right? Halfway in between them, that's x3. Okay. And then halfway in between x3 and x5, right? So that would be like 5.5 here. That would be my x4. Halfway in between x1 and x3, right? That would be my x2, right over here at 4.5, right? So then now, if I want to know where my y4 is, I have to trace my way up until it touches the graph of the function, right? Right over here. Why did it do that? Right over here. Okay. That point, right, is my y4. Okay. Fair enough. Okay. So now, right, now that I know my y4, the amplitude is the distance between that y value and the axis of symmetry. Okay, so that's my amplitude there, which is just 1/2 unit. No, half a unit there. Okay. I'm going to show it again with x2, right? So if we look at x2 over here, we could trace up to where it touches the graph of the function, which is right over here. And the distance between this point, right, and the axis of symmetry, right, is half a unit. So that's my amplitude again, right? Okay. So any questions on that? All right. So then I'm just going to copy this down over here. So the amplitude is equal to 1/2. Great. Okay. The horizontal shift is equal to 1. Okay. The vertical shift, forgot about that, is equal to 1 as well. And then the period is equal to 2. Okay. Okay. Any questions on that? Now notice this is a right side up tangent graph, right? So the regular tangent graph looks like this, starts from negative infinity and goes up to positive infinity, right? So this is right side up, which means that your amplitude is going to be, your A is going to be positive, right? So the amplitude is always the absolute value of A, which in this case will be positive A, right? Okay. And so that's going to be equal to 1/2. Okay. Vertical shift is always equal to D, which in this case is 1. Okay. All right. Now we'll do our period here. So the period for sine and cosine is 2 pi divided by b, but now we're talking about tangent and cotangent, right? So the period for tangent and cotangent is pi divided by b instead, right? Fair enough, pi divided by b. So we're going to say that that's going to be equal to 2, right? And then now we can solve for b. We can multiply by b on both sides. We get pi is equal to 2b, right? And then now we can divide by 2 on both sides. We get b is equal to pi divided by 2, okay? Right. Now we can do the horizontal shift. Let me scroll up a little bit so we can make sure we can read this. My horizontal shift is always C divided by B. Okay. C divided by B. Okay, so I think we found out that our horizontal shift was 1. Let me just double check that. Yeah. Okay. Okay. So then now we get just multiply by b on both sides, and we get c is equal to b. So we multiply by b on both sides, right? And so that means that c is equal to pi over 2 also. Okay. Now the very last step is just to write your equation here. So y is equal to positive 1/2, right, times tangent of pi over 2 times x minus pi over 2, and then plus 1. Bless you. Okay, so that's my final answer there. Yes. Uh-huh. So that would be incorrect for tangent. Yeah. For tangent, that would be incorrect. Yeah, because tangent, you're supposed to have that it goes through the y-axis itself at that middle key point. Okay. Yeah. So your horizontal shift should be measured by how far away your middle key point is away from the y-axis then. Okay. Yeah. But for cotangent, it would be exactly right. Yeah. So I'll talk about cotangent now. Okay. All right. Any questions on that? Okay. All right. Let's go on to problem 4 then. Right. So now we're talking about cotangent. And I'm basically going to use the exact same period to do my cotangent wave. So here it starts at a vertical asymptote. It ends at the next vertical asymptote. Okay, and then I'll just trace the graph in between there. Okay, so that's my cotangent graph. Thing about it though is that cotangent is supposed to look like this, as vertical asymptotes, and it's supposed to start at positive infinity and work its way down to negative infinity. That's the way it's supposed to look. Now, so this thing is an upside down tangent graph. Or sorry, upside down cotangent graph. Okay, fair enough. Now, where are my axes supposed to be? Well, your first, your y-axis, I should call it, is supposed to be right at this first vertical asymptote. Now, that's true for a cotangent graph. Okay, your x-axis is supposed to go right through that middle key point over there. Okay, there's your x-axis, there's your y-axis. Okay. All right. So keep that in mind as we talk about horizontal shift in just a second. Okay. So now let's just go ahead and label the same features on here, right? So the distance between your vertical asymptotes, that's your period, which is 2, right? Same thing that we did for tangent, right? Your vertical shift is still 1, right? Wherever your axis of symmetry is, right? Your amplitude, I won't go through it again, but it's the distance between the axis of symmetry and wherever your y2 is, right? So that's your amplitude there, which is going to be 1/2. Okay. So it's the same parameters as you had for tangent, right? Okay. Yeah, your amplitude, your period, and your vertical shift are all the same. The only thing that changes is your horizontal shift. Okay. So your horizontal shift is going to be, in this case, 0, right? Because that vertical asymptote where you're starting your cotangent graph is supposed to be right on the y-axis, and it is. Yeah. So then your horizontal shift is just going to be 0. Okay. So any questions on that? Yeah, so when we're looking at the cotangent graph, right, it looks like this, where your vertical asymptote is supposed to be right on the y-axis. So if it is on the y-axis, then that's exactly where it's supposed to be, which means you haven't shifted it at all. Okay, fair enough. Or you haven't shifted it horizontally at all, I should say. All right, so I'm going to copy that stuff down over here. So your amplitude is 1/2 still, right? Your vertical shift is 1. Your horizontal shift is 0, and your period is 2. Okay. Yeah. All right. So now that we have that, the amplitude is always the absolute value of A. But as we noted earlier, this is an upside down cotangent graph, right? So in that case, we're going to have negative A. Okay. So negative A would be equal to 1/2, which means that my A is negative 1/2. Okay. Yeah, that would be good. Yeah. Okay. Vertical shift is D, right? It's always D, so it's going to be equal to 1. Okay. Period is still pi divided by B, right? So here my period is 2. So that means that B is going to be equal to pi over 2. Right? I already showed my algebra for that last time, so I can just leave it like that. Okay. And then now horizontal shift is C divided by B. But in this case, my horizontal shift is 0, right? So that means that my C must be equal to 0. Okay. Now we just put it all together. Y is equal to negative 1/2 cotangent of pi over 2x. And then outside we do plus 1. Okay. There we go. Any questions on that? Any questions on that? All right. So now comes the part where we actually have to graph something, right? So this is going to be graphing the sine wave and this cosecant function on the same axes, okay? Right? So looking back at this, right? Remember that the general form that sine comes in is this a sine of bx minus c plus d, right? So then I can read off immediately that my a is negative 1, right? My b is positive pi over 2. My c is positive pi, right? Because that minus sign is built in there, right? And my d is 2. Okay, fair enough. Any questions on that? All right. So the first step in this is, just graph the sine function, right? Yeah. So we did a bunch of graphs of sine, so it shouldn't be so bad graphing the sine function. So step 1 over here, right, will be just computing what the period is and what the horizontal shift is. Okay. So the period is always 2 pi divided by b for any sine wave or for any cosine wave, right? So we have that our b is pi over 2, right? So we have 2 pi divided by pi over 2. Use parentheses, they will help, right? Okay. So this is the same thing as 2 pi times the reciprocal of pi over 2. Okay. So my pi's are going to cancel off. I'm going to get my period is 4. Okay. Any questions on that? Any questions at all? Okay. So now that we have that, right, now we can do our horizontal shift, right? Our horizontal shift is always C divided by B. Okay. So my C here is pi. My B here is pi over 2. Okay. Use parentheses, right? And so this is going to be pi, right? Oh, sorry. Leave myself a little bit of space there. We have pi times the reciprocal of pi over 2, right? So my pi's are going to cancel off, and I'm just going to be left with 2. So now I have my period and my horizontal shift. That's step 1. I mean, you could compute the amplitude too if you wanted to. You could compute the vertical shift if you wanted to. It just doesn't necessarily help us to compute that. Yeah, fair enough. All right, so that's step 1. Any questions on that? Any questions at all? Yeah. Don't worry about that. Yeah. Just do the period and the horizontal shift for step 1 there. Those are the ones that are absolutely essential in order to find the key points, right? Yeah. So definitely do the period and the horizontal shift. Okay. All right, so let's go on to step 2, where we're going to do our x values of our key points, right? So our first key point, our x1, is always just wherever your horizontal shift is, right? So it's just 2. Yeah. Okay. Our x2 is always x1 plus a quarter of the period, right? Take 1/4 of the period and add it to x1, right? Which is really nice in this case because a quarter of the period would just be 1 unit, right? Yeah. The period's 4, so a quarter of that's just 1, right? So then we're going to take x1 and add 1 to it. We're going to get 3. Right? X3 is just x2 plus a quarter of the period, right? So we're going to get 4, right? x4 is just x3 plus a quarter of the period. So we're going to get 5, right? And then x5 is just x4 plus a quarter of the period. So we're going to get 6. So 3, 4, 5, 6, right? Or 2, 3, 4, 5, 6. Okay. Any questions on that? Any questions at all? All right. Now we'll do the y values, right? So we have y1, y2, y3, y4, and y5. Okay. And so to compute your y values, I'm going to use the y values for just plain sine of x, which is 0, 1, 0, -1, and 0. Okay. And then now all of these get multiplied by a, whatever your a is. And then d gets added to it. All right. So these are basically the outputs of whatever your sine function is. It's 0, 1, 0, -1, and 0. So then you multiply that by a, and then d gets added to it. Okay. So my a is -1, my d is equal to 2. Okay. So then I'm going to go ahead and plug that in. So this is -1 times 0 plus 2, right? -1 times 1 plus 2, right? -1 times 0 plus 2, right? And so on. Yeah, yeah. That's perfectly fine. Yeah, in fact, let me go ahead and pull up a calculator so we can show how to do that in a calculator really quickly as well. Yeah, okay. Okay, I'm going to finish this part and then I'll do that. All right. So then our y1, right, when we go ahead and simplify this, we're going to get 2 here. All right, we're going to get 1 here. We're going to get a 2 here. We're going to get a 3 here. And we're going to get a 2 here, right? Okay. Yeah. Any questions on that? All right. So you could find your y values, like I said, by using your old y values for sine, 0, 1, 0, -1, and 0, multiplying them by a and adding d to them. But you could also just get them from like plugging them into a calculator, right? So let me clear out all this crap over here. All right. And I'll let y1 be the sine wave that I have in this problem here, right? So that should be a negative sine of pi over 2 times x minus pi, and then plus 2 on the outside. And I just want to make sure that I'm in radians here. Good. Okay. It's very important to be in radians. So if I go back to y equals, you can see that I've plugged in my my sine wave right there, the equation, right? Now to find the y values, well, I have the x values right here. So I just need to plug in these x values to find my y values, right? So I'm going to go to vars here, go to y vars, right? Just by pressing right, and then go to function, go to y1, and then I'm going to find out what the y value is when x is equal to 2. And I get 2, right? Now I'm going to find the y value when x is equal to 3. And I get 1, right? And now I'm going to find the y value when x is equal to 4. And I get 2, right? And now I'm going to find the y value when x is equal to 5. And you get 3, and so on, right? So you could do it that way as well. That's perfectly fine, right? You just write y1 equals 2, y2 equals 1, y3 equals 2, y4 equals 3, y5 equals 2, right? If you want to use the calculator, that's all the work you need to show. Okay, fair enough. Now, if you plug this into your calculator wrong, you're going to get crazy numbers, right? Yeah, fair enough. Yeah, you're going to get things that aren't even like rational numbers or not whole numbers, not just weird irrational numbers. Yeah, and so like you do have to be a little bit careful about that. You got to make sure that you're in radians, not degrees as well. Okay. Yeah. So now I have my x values, I have my y values. Now we just plot the points, right? And I'm going to start off by putting in my axis of symmetry, right? So my axis of symmetry is wherever D is, so that's at 2, right? So I'm going to do a little axis of symmetry over here at y equals 2. Okay. There we go. And then now I'm going to plot my points. So 2, 2, right? And then 3, 1, and then 4, 2, and then 5, 3, and then 6, 2. And then now I'm just going to connect it on up. Okay. Fair enough. Any questions on that? The formula that I put into the calculator? Hold on one second. You mean when I clicked on y equals over here, this right here? Yeah, there we go. Okay. All right, so that's my sine wave, and that's like, full credit for the sine wave right there. Okay, if you just left that much, that's good. I like to put a little bit extra in there, right? I mean, it's a periodic function, and I had this whole graph right over here. So why don't I just draw like a little bit more, kind of fill it out, right? So like over here we'd have 7, 1, we'd have 8, 2, so we could keep on going this way. Right over here we would have 1, 3, we'd have 2, 2, so we could go this way as well, right? We can go down to here and so on, right? Just to have a little bit more in there. Okay. Now, so now that I'm done with that, the last step is to draw the graph of cosecant, right? And that should be really easy. So I'm going to do this in blue. Okay. Anywhere where we're touching the axis of symmetry, that's going to be a vertical asymptote for cosecant because they're reciprocals of each other. This would be like where sine is symmetric about. So you're going to get that this is like 0 for sine, basically. And so cosecant's going to be undefined there. Okay. So over here, we're going to have a vertical asymptote. Okay. Over here, we're going to have a vertical asymptote. I imagine you're going to need at least 2 periods to draw the graph of cosecant and secant. Right. Or really, yeah, you only need 1 period to draw the graph of cosecant. It's just you're not going to see that nice secant. So when we do the secant problem, you're not going to see that nice graph of secant unless you go a little bit beyond. Yeah, well, so I'll show you when we get to the cosine secant. Yeah. It's not so much an issue for sine and cosine, but yeah. Okay. All right, so then now I'm going to draw the graph of cosecant. So the rule is, yeah, we have the vertical asymptotes wherever sine touches the axis of symmetry, right? And then the other rule is if we have a maximum or minimum point of sine, that's also a point that lies on cosecant, okay? So all the maximum and minimum points, okay? Okay. And then now anywhere we have a maximum point for sine, that's going to correspond to a U shape for secant. Oh, sorry, for cosecant, right? So here we're going to have a U shape up here as well. Okay. Yeah, so it touches right at there and does a U shape, goes to positive infinity in both directions, right? Make sure it doesn't cross your vertical asymptote. It's impossible to cross a vertical asymptote. Yeah. All right, and then anywhere where we have a minimum y value, that's going to correspond to an upside down U shape for cosecant. So we have that. Okay. Down like that. Does not have to be perfect. Okay. I forgot to put in this vertical asymptote over there. There we go. Okay. And there we have it. Okay. So any questions on that? Any questions on that? Yeah. Yeah, that's perfectly fine. Yeah. Yeah. That looks good. Yeah.
This type of stuff can be like most
What was that?
it's type of stuff like graphs and everything can be most of the exam.
Oh, yeah, so this is practice exam, looks exactly like the real exam. Yeah, so like the first like 6 problems is graphing. Yeah. And to be fair, the last 3 weeks we've been spending on graphing, right? So, of course that's going to be the majority of the exam, right? So, yeah. Yeah, so
So that kind of how it's gonna be.
So-
Or that.
you said the midline? The axis of symmetry or? Well, for this one it's 2. Oh, yeah. Yeah, it should be pretty similar. Yeah. Should be pretty similar. Yeah. Okay. So for example, problems 1 and 2 on the actual exam, they'll be the same graph. It's just you're going to treat one as a sine, the other one as a cosine, right? And then problems 3 and 4 are going to be the same graph. You just have to treat one as tangent, the other one as cotangent, right? Yeah. Yeah. Yeah, 7. Yeah. Yeah. Okay. So then now, let's plot the graph of cosine, right? Okay. So again, I'm just going to read off what my A, B, C, and D are, right? So I have my A is -1, my B is positive pi over 2, my C is positive pi, and my D is positive 2. Okay. Fair enough. All right, and then now that I have that, I can go ahead and compute a few things. So my step one here, we're going to do the period. Okay. Now, if you want, I think these are the same parameters we did in problem 5, right? The same A, B, C, and D, right? So if you want, you can just go ahead and say that your B is going to be the same as it was in the previous problem, right? So 2 pi over B, your B is going to be equal to 4, right? Oh, sorry, I don't know why I said B is equal to 4. Your period, rather, is going to be equal to 2. Is that right? No, pi over 2. I'm thinking about a different problem. Sorry, everybody. Yeah. So 2 pi over 4 is pi over 2. Now your horizontal shift is C divided by B, right? So that's going to be pi divided by pi over 2, right? So your horizontal shift in this case is going to be, let's see, pi divided by pi over 2 is 2, right? Okay. So now that we have that, now we can go on and compute our x values of our key points, okay? Our x values of our key points. But they're the same x values as before, right? Because we had the same horizontal shift, right? We had the exact same horizontal shift, right? We had the exact same period, right? So then this is going to go 2, 3, 4, 5, and 6, right? You can just reuse what you did for problem 5, right? Okay. Your y values are going to be different though. Which again, you can get it by plugging it into a calculator, right? Computing your y values, or you could use your old y values for cosine, right? So the old y values for cosine are 1, 0, -1, 0, 1. Okay. And then you multiply all of those by a. And then you add d to all those. Right? Okay, so here you're going to get this is a 1, and this one right over here is a 2, and this is a 3, and this is a 2, and this is a 1, right? Fair enough. So any questions on that? Hold on one second. So my a here was -1. My a here was also -1? Okay. Oh, yeah, we're good. We're good. Just making sure I drew the graph right. Okay. Yes, always. Yeah. Okay. For sine and cosine. Yeah. For tangent, you start to. So yeah, for tangent, which is why I didn't do this, it would be your middle key point is where your horizontal shift would be. Yeah, so your x3 would be horizontal shift for tangent. Yeah. So that's why we didn't do that one. Okay. All right. So then now I'm going to start off the same way, putting in my my axis of symmetry here at y equals 2, because my d is 2, right? Okay. And then now I'm just going to go ahead and plot my points. So I have 2, 1, I have 3, 2, right? I have 4, 3, I have 5, 2, and I have 5, 2. Yep. And then I have 6, 1. Okay. Fair enough. Now, when you go to draw the graph of this, remember that it's supposed to be curvy, right? Yeah. So it's supposed to curve upwards from here like this, right? It's supposed to curve downwards to the next point, downwards to the next point, and then upwards to the next point, right? Fair enough. Okay. And so this is one where I'd like to extend the graph out a little bit. And so we'll see why. I'm going to go ahead and draw the extended graph in green here. So it's going to go up like that, over like that, down like that. Okay. Up like this, over like this, down like that, and so on. Okay. And so we're going to draw the graph of secant now, and it's going to be the exact same process that we did for cosecant, right? Anywhere where cosine is touching the axis of symmetry, that's going to correspond to a vertical asymptote for secant, okay? So I'm going to go ahead and draw that in there. There's a vertical asymptote. And so if we just looked at the red graph, right? If we just looked at the red part of this graph right over here where I've drawn like one period of cosine, right? Then if I draw secant, it looks like this, right? Okay. And then like we kind of don't see everything else. We just like leave that one just that one period of cosine. Like we can see that it's going to go down like this. It's going to go down like this, right? But I want to see like more of the secant graph. Yeah. So that's why I wanted to extend the graph out so we could see a little bit more detail, right? So everywhere where the cosine graph touches the axis of symmetry should be a vertical asymptote. So right over here should be another vertical asymptote, right? Right over here should be another vertical asymptote, right? I want to at least see those U shapes and those upside down U shapes, right? Okay, so that's good enough right there. Yeah, I basically say like show me more of the graph, basically. Yeah, so I'd probably take off a point for that if you don't show like at least the full graph of secant, basically like that. Yeah. Okay. Yeah. Okay. So any questions on that? All right. And we could keep going, of course. All right. Go up there and up there. All right. So then over here we could go like that and over there. Yeah. Another vertical asymptote. Just one up and two down will be fine, right? As long as I see like a full U shape and a full upside down U shape with the vertical asymptotes between them. Yeah. Okay. Okay. Oh, sorry. Were there any questions on that? Okay. For the last problem, I was going to ask a little bit more than just one question on inverse trig functions. But the test is already getting kind of long. I don't like to have more than 6 questions, and I already have 7. So we're just going to have one question on inverse trig functions. Okay. Right. So over here we have cosecant of arcsecant of -3. Okay, cosecant of arcsecant of -3. And we're trying to evaluate that. Okay. So let's let theta be equal to arcsecant of -3. Okay. And we're going to define theta to be arcsecant of -3 because arcsecant, as all inverse trig functions do, you plug in a real number and it gives you an angle, right? Fair enough. But now we don't know anything about arc cosecant, arcsecant, and arc cotangent. And we don't need to know anything about it. We can use this reciprocal relationship. Arcsecant of -3 is the same thing as arc cosine of 1 divided by -3. Okay. So saying that theta is arcsecant of -3 is exactly the same thing as saying that theta is equal to arc cosine of -1/3. Okay. And the advantage to doing that is that we know everything about arc cosine. Okay. Everything that we need to know about arc cosine, we already know. Right. Fair enough. So now that I have that, right, this means that cosine of theta must be equal to -1/3. Okay. But what is the range of arc cosine again? 0 to pi. Yeah, exactly. So for arcsine and arctangent, it goes from -pi/2 to pi/2. But for arc cosine, it goes from 0 all the way to pi, right? Okay. So then cosine of theta is equal to -1/3 for some theta between 0 and pi, right? So that means it has to be either in quadrant 1 or quadrant 2. So which one is it? Is it quadrant 1 or is it quadrant 2? Yeah, it has to be quadrant 2. And why is that? Because cosine is negative, right? Yeah, because cosine is negative, exactly. Right. Yeah. Cosine's positive in quadrant 1, so it couldn't possibly be in quadrant 1, right? So it has to be quadrant 2. Of the 2 quadrants it could have been, it has to be quadrant 2, right? So theta is in quadrant 2 since cosine of theta is less than 0. Now you can say in quadrant 2, but I figured I should write it out for you guys anyway, right? Yeah. So yeah. It is important that you do tell me that it's in quadrant 2, though, because now you're going to draw the angle over here, right? So here's an angle that's in quadrant 2. Doesn't have to be to scale or anything. I don't know what this angle should be. Okay. So we have a point over here. It has an x coordinate and a y coordinate, right? Fair enough. It also has an r, which is the distance that point is from the origin, right? And that's given by the square root of x squared plus y squared, right? Equivalently, we have r squared is equal to x squared plus y squared. You can use either form you want. Okay. All right, but now that I have that, right, let's recall that cosine of theta for an angle in standard position cosine of theta is always the x coordinate over the distance, the origin, right? X over r, right? So we have that this is equal to -1 divided by 3, where I put the negative in the numerator, okay? And so it's pretty easy to say why we're putting the negative in the numerator. And the easy reason is because r is always a positive number. So the negative should definitely not go in the denominator there, right? Fair enough. You only really have to think about it if you're doing tangent or cotangent. Yeah, because tangent is y over x, cotangent is x over y. So you have to think, all right, in which quadrant am I in? Is x positive or negative? Is y positive or negative, right? Yeah, so that's the only time you really have to think about it. But cosine of theta is equal to x over r, which is equal to -1 over 3. So then x can be equal to -1, r can be equal to 3, and now I can solve for y, right? Okay, so remember I have x squared plus y squared is equal to r squared, right? So I have -1 quantity squared plus y squared is equal to 3 squared. Use parentheses, they are your friends, okay? So we get y squared is equal to 8, which means that y is equal to the square root of 8, well, plus or minus the square root of 8, right? Which is the same thing as plus or minus 2 square root of 2, right? And then now, since we're in quadrant 2, y should be positive, so then this will be positive 2 square root of 2 since quadrant 2, right? Okay, so now we have our x and our y and our r. Any questions on that so far? Any questions on that at all? All right, good. So then now we're trying to compute cosecant of arcsecant of -3. So cosecant of arcsecant of -3. Well, we started off by letting theta be equal to arcsecant of -3. So really it's just the same thing as cosecant of theta. Okay. Yeah. And then now we've already drawn this nice picture of theta there in quadrant 2. So cosecant of theta will just be equal to r divided by y, right? Using our formulas for cosecant for an angle and standard position. Yeah. Okay. All that test 1 stuff, right? So my r was equal to something. 3? Yeah. And my y was 2 square root of 2, right? So then now I have to rationalize it. So I'm going to get that this is like a 3 square root of 2 over 4, right? And that's what cosecant of arcsecant of -3 is. 3 square root of 2 over 4. Was it cosine? No, it's cosecant. Yeah, cosecant. It's a bit fuzzy, so it's kind of hard to see. Yeah. Okay. Any questions on that, though? If you're looking for more practice with something like this, right? Just try changing the functions, right? Try changing it to secant of arc cosine, right? Try changing it to tangent of arc cosecant of -3, right? You know, just try a few different functions out, you know, see what happens. Okay. How do you know if you got it right? Plug it into a calculator, right? See if you got the right thing or not. Yeah. What was that? Oh, scroll down. Yeah. No problem. Yeah. Yeah. Oh, so I'm not going to ask you to graph a tangent or a cotangent. Yeah, because it gets a little too crazy. Yeah. So yeah, you have to know how to graph sine and cosine, and of course their inverses, which I mean not inverses, but they're reciprocals, right? Yeah. So yeah. Okay, I'm gonna go ahead and stop the recording anyway.